So it's time to stop and check in and see what the James Webb Telescope has been up to lately. I don't know. I feel like it's a member of my family. I feel like I'm checking in on it like it's a kid that I sent away to college or something. Just need to see what's going on, what's new with it, what's happening, what's the latest, greatest, all that type of stuff like that. All right. This video here, man, is NASA's James Webb discovers 6 new galaxies that should not exist. Now, how can we even begin to make the claim or the statement that it should not exist? But I ain't even gonna get into that. We're gonna get into the video. So if you're new, you know what to do. Hit that subscribe button and join the fam, man. And let's see what's going on.
Astronomers have made an unexpected discovery using the James Webb Space Telescope. It spotted 6 massive galaxies that existed between 500 million and 700 million years after the Big Bang that created the universe.
Astonishing new images captured by the Webb telescope have revealed 6 massive galaxies, each filled with mature stars, all formed just 500 to 700 million years after the Big Bang. But what's even more surprising is that these galaxies are 50 times more massive than scientists previously thought possible for their early formation. And the stars inside these ancient galaxies are not the bright blue ones expected in early galaxies, but old red stars. These findings challenge our fundamental understanding of galaxy formation and evolution.
And that can't help me but think that there's other life out there if we got 6 new galaxies that we've just discovered, fam. What do you, again, I'm not that naive, man. I just can't sit here and say that we're the only ones. We're huge galaxies, but we're the only ones. We're the only ones that, you know, the right situation came about and we were formed. I just not saying that it isn't true. It could be, I just can't see it.
Challenge our fundamental understanding of galaxy formation and evolution. Join us on this thrilling journey as we unravel the mysteries of the early universe and the galaxies that defy all expectations. This is a journey that has rocked the foundations of astronomy, and the implications are nothing short of astonishing. Unraveling the enigma of an astonishing discovery.
The James Webb Telescope has identified 6 galaxies that exist 500 million years after the Big Bang that are up to 10 times bigger than the Milky Way galaxy. That shouldn't happen. Something is wrong. We may have to revise our theory of the creation of the universe.
That's never good. One, he said, this shouldn't happen. Something's wrong. 2 things that don't sit right with me, bro. You know what I'm saying? Something ain't right. Something's going on. We need to pay attention, fam. It's probably done scared him to where his hair color is that color right now. I don't know.
Wrong. We may have to revise our theory of the creation of the universe.
December 25th, 2021 marked a momentous day, not only for the general populace, but also for the scientific community. It was the day that the highly anticipated James Webb Telescope, a product of the hard work of over 20,000 engineers and hundreds of scientists from all over the world, was finally launched. After a long wait, the effort finally paid off as NASA's newest observatory made a plethora of incredible discoveries within just 6 months of operation. But one of these discoveries has baffled scientists and left them scratching their heads. You see, during the early observation campaign of the James Webb Space Telescope, an intriguing image was captured featuring 6 new galaxies. These galaxies are nearly as massive as the Milky Way, filled with mature stars and scattered.
No, we can't just breeze past that. I was trying to read it fast. I know y'all was. Y'all probably faster readers than me, but I couldn't read it that fast. It said the JWST just revealed 6 massive galaxies that scientists thought could not exist, potentially shattering our scientific understanding of the universe. I appeared on NBC in News Now to discuss this groundbreaking discoveries plus new revelations here on Earth. So now what's to come of this? What do we go back and say now? What does that mean for everything we've ever known or thought how things happen? You know?
Nearly as massive as the Milky Way, filled with mature stars and scattered across the image. Despite their size, they only appear as tiny reddish dots to the powerful telescope. And upon further analysis, scientists were surprised to discover that they were observing these unexpected galaxies during the universe's infancy, around 500 to 700 million years after the Big Bang. But that's not all that was peculiar about these galaxies. The initial estimate of their mass, nearly 1 billion suns, was completely blown out of the water by the Webb telescope's deep field image.
It was kind of shocking because some of these galaxies were 13 billion light years away, and they had 100 billion solar mass of the stars. And so what that means is that we are viewing these galaxies very shortly after the Big Bang, only 600 million years after the Big Bang. I know it sounds like a lot, 600 million years, but our universe is 13.8 billion years old. So we're really looking at the infant universe when it was only 5% of its current age.
In reality, these galaxies were a mind-boggling 50 times more massive than originally thought.
So if we're older, if I'm understanding this correctly, if we're older than these new 6 galaxies that just, in my mind, have been hiding in plain sight, we just have never got a chance to view them. If they're bigger than us, then are we shrinking down? Are we, what's going on with us? What does that say about us in relation to the size of them? And they're younger. That don't make me feel good about us.
A mind-boggling 50 times more massive than originally thought, leaving scientists grappling to understand how such massive galaxies could have formed so early in the universe's history. And as if that weren't enough, the stars present in these galaxies were surprisingly big and old. Previous observations from the Hubble Space Telescope suggested that young stars in early galaxies were small and bright blue. However, the JWST's observations of these ancient galaxies showed the presence of old red stars, which were unexpected. The unexpected discovery has challenged 2 very important foundational theories about how galaxies form and evolve in our universe. The false...
And I might have made a mistake and been saying, I don't know if I've been saying universe, I meant galaxy. So how does that play out for our galaxy? That's what I meant to say if I didn't say it. I couldn't remember or not.
About how galaxies form and evolve in our universe. The false roles of supermassive black holes.
These are not baby galaxies at all. They're actually monstrous black holes. Black holes that formed after the instant of creation. That's baffling scientists because they don't fit in the normal sequence of the birth of a galaxy. So I personally think that we're actually looking at monster black holes where perhaps new laws of physics are emerging. And again, if you can figure all this out, there could be a Nobel Prize waiting for you.
The discovery of unexpected, massive, and evolved galaxies in the early universe challenges some existing theories about the formation and evolution of galaxies. One of the theories that...
You know what's crazy about it, though? It's crazy when somebody who knows the seriousness of it but can't do nothing but laugh when they talk about it. You know what I mean? That's when you know it's just mind-blowing to an extent. Listen to the entire time he's talking, bro. He's laughing at the same time because he's like, I have no idea what's going on here. This is just probably erased everything he's ever known about the galaxy and the universe. You know what I mean?
So I personally think that we're actually looking at monster black holes where perhaps new laws of physics are emerging. And again, if you can figure all this out, there could be a Nobel Prize waiting for you.
The discovery of unexpected, massive, and evolved galaxies in the early universe challenges some existing theories about the formation and evolution of galaxies. One of the theories that has been effected is related to the role of supermassive black holes in galaxy formation. According to this theory, supermassive black holes, which are millions or billions of times more massive than the Sun, play a crucial role in regulating the growth of galaxies. The theory proposes that when galaxies form, they accumulate gas and dust that eventually collapses under gravity to form Mars. However, the growth of the galaxy and its central supermassive black hole are interdependent, meaning that the black hole's growth can also influence the growth of the galaxy. In particular, the theory suggests that supermassive black holes can limit the growth of galaxies by expelling and heating up gas that would otherwise form new stars. This process, known as AGN feedback, occurs when the black hole accretes gas and dust from its surroundings, releasing powerful jets of energy that can affect the surrounding gas and dust. So what do I mean? Well, most of us played Pac-Man while growing up. To some of us, it's part of our childhood we may never let go of. So, let's imagine the universe is like a giant game of Pac-Man. The universe is represented by the Pac-Man game board, with Pac-Man representing galaxies and the dots he eats representing stars. In the center of the game board is a supermassive black hole, represented by the ghosts in Pac-Man. Just like how the ghosts chase Pac-Man around the board, the supermassive black hole attracts galaxies and influences their movements. In the game of Pac-Man, when Pac-Man eats a large power pellet, he becomes invincible. In the universe, galaxies can also become invincible thanks to feedback from the supermassive black hole. The supermassive black hole produces jets of energy and radiation, represented by Pac-Man's power pellets. These jets can blast out of the center of the galaxy, hitting the gas and dust around it. This feedback can help regulate the formation of stars and galaxies, preventing them from growing too large or too small. However, the recent discovery made by the James Webb Space...
So black holes have a significant amount of importance to us. Good to know now. They also still scare the bejesus out of me though, because it destroys everything in its path. You know what I mean? From what we've heard, the gravitational pull from it that pulls you in and doesn't let anything out of it, not even light.
Small. However, the recent discovery made by the James Webb Space Telescope challenges the idea that supermassive black holes always play this feedback role because it suggests that the growth of some galaxies may have been less influenced by the presence of a central supermassive black hole than previously thought. It's possible that some galaxies were able to form and grow to large sizes without the presence of a black hole, or that the black holes in these galaxies were not as influential in regarding their growth as previously believed. Cold, dark matter. Another theory that is challenged by the Webb Space Telescope's latest find is the cold, dark matter theory. A hypothesis that suggests that most of the matter in the universe is made up of a type of invisible, non-luminous material known as dark matter.
But at the same time, I heard another video kind of debunk that and say that could, since we don't know or have fully understanding of what dark matter is, could suggest that we're inside of a black hole. So...
Now, the idea of dark matter was first proposed in the 1930s, when astronomers observed that galaxies were rotating much faster than they should be, based on the amount of visible matter they contained. This insinuated that there was some kind of invisible matter providing additional gravitational pull to hold the galaxies together. In a much simpler sense, imagine two kids holding hands and spinning in a circle together. As they spin faster and faster, they might start to feel a force pulling them apart. Now, let's say that these two kids are the stars in a galaxy, and the force pulling them apart is the gravitational force that should be caused by the visible matter in the galaxy. But when astronomers measure the speed at which the stars are moving, they find that the gravitational force from the visible matter isn't strong enough to keep the stars, or in this case, the kids, in their orbits. It's as if there's some invisible force holding them together. This is where dark matter comes in. Scientists believe that dark matter is a type of matter that doesn't interact with light or other forms of electromagnetic radiation, which is why we can't see it directly. But it does have mass, which means it exerts a gravitational force. But the cold dark matter theory takes things a step further by suggesting that the dark matter is cold, meaning that its particles move relatively slowly compared to the speed of light, like Pac-Man moving slowly when he eats up the dots. This is in contrast to hot dark matter, which would consist of particles that move at close to the speed of light, like Pac-Man when he eats a power pellet. The cold aspect of cold dark matter is important because it helps explain how structures like galaxies and galaxy clusters could have formed. According to the theory, dark matter particulates started coming together under gravity, forming big clouds. These clouds then attracted other matter like gas, which eventually led to the formation of galaxies and groups of galaxies. However, recent discoveries by the James Webb Space Telescope suggest that the theory may need to be revised or refined, since it does not fully account for the large number of distant galaxies that have been observed. The discovery made by the James Webb Space Telescope challenges long-held theories about how galaxies form and evolve in our universe. It's a reminder that even our most deeply held beliefs about the cosmos are subject to change, and that there is always more to learn. The James Webb Telescope's latest find is a testament to the power of curiosity and exploration, and it's a reminder of the incredible potential of human ingenuity. Did you enjoy the video? Why don't you check out these other ones? And don't forget to drop a like and subscribe to the channel if you're new.
So what does that mean? I enjoyed the video, but I left a little bit more confused. And why do I feel like dark matter is just, I don't know, you know when you were in math class and they always talked about the unknown? I just feel like that's the unknown in the equation and they just labeling it something to make sense of what's going on. They say it's just like saying it's some factor out there that we're not accounting for, or it's something that's got to be doing this, and we're just gonna call it dark matter, and we don't know what it is or what. Like, I feel like that's what's going on. Like, I don't know, man. Something's not right, and we just ain't figured it out. And when you do, it's a Nobel Peace Prize waiting for you at the end of it. That's all I'm gonna say. You know what I'm saying? Y'all get at me in the comment section, man, and let me know what y'all thought of this video. Super interesting though, nonetheless, man. I always like it when they say it changes everything we've ever known about something. So the Big Bang and all that. The Big Bang has been in question for a while now anyway. So, but till the next one, I'm gone, man. Peace.